So today we'll be looking at Huygens principle, and I know it's not pronounced Huygens principle, but sadly I'm not Dutch, so I can't pronounce his name properly. Sorry. But for the purposes of this video, we'll just call this Huygens principle. So to understand what this principle means, we have to look at what wavefronts are. So let's draw a set of waves. And you'll see that these waves are in phase. We're going to look at the crests of these waves. And if we draw a line connecting all of these crests together, these two lines are wavefronts. So let's draw these wavefronts again. Right here. So what Huygens proposed was that on this wavefront, any point on this wavefront can be a point source for a spherical wave that looks like this. And this picture is shown in the textbook as well. And there's a point where all of these spherical waves touch this line right here. That's tangent to all these spherical waves. This is the next wavefront. And similarly, there are also points or point sources that will have spherical waves. Again, the line tangent to all of these spherical waves, this is the next wavefront. And between each wavefront here, this is the wavelength lambda. So now, let's clear this, and we're going to look at Huygens principle from a perspective of what we see in our everyday lives. So, let's say there's a lake, and you're on a bridge right here, and you say, wow, that's so pretty, and you want to take a picture, so you take out your phone, but oh no, you accidentally drop it in the lake. Darn. So it falls here. So what happens when your phone falls into the lake? Well, there are spherical propagations. There are waves. Now let's look at this at a closer level and apply Huygens principle. This is where your phone dropped. This is a point source. Now similar to this point source that we drew earlier, there's a spherical wave. Again, spherical wave. Each point on this spherical wavefront are point sources. So I'll draw semicircles. And the curve that's tangent to all of these spherical waves, this is the next wavefront right here. And this will continue on and on. And this is generally what you see when you drop something into the water, or in this case, your phone. So now, let's look at Huygens principle with regards to plane waves. So what are plane waves actually? So let's try drawing this out. So it looks like this. It's just like this. Now notice this line, and this line. These are wavefronts. So what does that tell you? Plane waves are essentially just wavefronts that are parallel to each other. In other words, this, if we looked at this from a bird's eye view from this way down, we would see this, which is something that we just saw earlier. These are the possible point sources. Now, what does Huygens principle have to do with these waves? Now, if you remember earlier, when we said when we wanted to predict where the next wavefront would be, we would look at the line that's tangent to all of these spherical waves. And this is exactly how the plane wave works. So the plane wave, let's say it travels this way, from left to right. This means that if we look at the wavefront on the very top, each of these spherical waves will lead to the next wavefront, and to the next wavefront, and to the next wavefront, moving from left to right, exactly like this plane wave. So what does this tell us? This tells us that plane waves are actually the superposition of many, 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 many spherical waves. And this is how Huygens principle can be applied to plane waves.